here we are with section 2 modeling. So modeling is a very interesting topic or subject in math, and it's really fun to have skills in building models, mathematical models. So for doing that, you guys need to know some basic geometric shapes like a square, rectangle, triangle, circle, right triangle, cube, cuboid. Cuboid is a rectangular box, and cylinder, sphere. So these shapes, if you can know how they look and if you can draw them on the paper. Also, you should understand the quantities which go with these objects like length, width, depth, height, area, volume,
I'm not quite sure how to help
surface
you with
area. So, and also formulas which connect these quantities. And also special formulas like the Pythagorean theorem, which is used when we have a right triangle. Now to model with the function, we follow these three or four steps, I should say. So the first thing is to express the model in words which which will be done for you, because that's how you will be writing the model. You'll get the word problem. So but your job will be to recognize what shape is required or what shape is being used in that problem, and then draw the shape, and then decide variables, and if possible place them in with the picture, with the drawing that you made. And then the next step is to set up the model. And how do you set up? That's where the equations come in. So let's see some examples here. First example, a rectangular box has a square base and top. The height of the box is half the width of the base. Okay, so let's try to draw this. So we have a square base and square top, and the height is half the width. So if this is my square, by the way, if you don't know how to draw a box, here is a very easy way. So we start the rhombus. I hope you guys know what a rhombus is. It's a square, just a little bit tilted, and then we draw another square just like this on top of it. How? Like this. That's just a small distance away. It doesn't have to be like that. We can move it a little bit in here. Okay. So now join this point, that point there, this here, and that point. So you see this is a box. So base, this base and this side, they are equal. That's why it is a square. So the question is telling us that it has a square base and square top, and the height is half the width of the box. Now we have to assign variables. So since it is mentioned here in the question, find a function that models the surface area A in terms of its width W. So it is given to us, so we must use the same letter for the width, which is W. Now if it is not given, then you can use any letter. So the area of the base will be W square, right? And area of top will also be W square. So we will come to that in a minute, but first thing is that what is the relation between height? If you say h is the height, Well, h is to be w over 2 because it's half the width. And so now we have to write what is the area, surface area of the box. So a box has 6 faces, and so we find the area of each face and then we add them. If it's a cube, all 6 faces have the same area. So if it's a w square, then all faces have w square, so we get 6w square. But in general, in the height and the width and the length or depth, they differ. Okay? So when they are different, then there are 3 terms, and which we add. Actually, there are 6 terms, but two of them are same, 2 are same, and so we combine them. There are a total of 6 terms if all length, width, and height are different. In our case, we have the length, you can say, and the width are the same, but the height is different. So we will have, you should know this. I mean, you don't have to write this in your solutions, but remember, the area of top will be the same as area of the bottom, and the area of front will be the same as area of the back. Area of the left side will be the same as area of the right side. So one by one, let's look at them. So you can see the top is a square with height, with length w, and it's, or each side w. So area of that will be w square. Now front, let's say this is the front, then it is a rectangle whose length is w and height is w over 2. So area for that one will be w square over 2. Now if we look at the side, so right side, for example, this is the right side. So it will be the same as the front. So it is w here and w over 2 here. So it has the same area as so these 4 sides of the box, they have the same area in this case, and then the base has a different area and top has a different area. So the area, surface area, will be sum of all these areas. Okay, so we can write now surface area. So we usually use big uppercase S and uppercase A for surface area is equal to w square for the bottom base plus w square for the top. Now sometimes you will see the question might say a rectangle box with an open top. Open top means you will not include the area of the top, so there will be only one w square term. But in this case, since it doesn't say open, so we will keep it. Plus, now we said all 4 sides are same, so we can say 4 times w square over 2. And now simplify. We have 2w square from here plus 2w square from the other term, and then which makes it, so 4 times, so this gives us 2w square, so which makes it 4w square. So that's the answer. That's your model. The surface area is going to be 4w square. Looking at the next example, it says the height of a cylinder is 3 less than twice the radius. So it says 3 less than, okay? So the number 3. So what does a cylinder look like? Like a can of Coke. So we have circle at the base, circle at the top. So the radius for both top and bottom will be the same. So the area of the base will be, do we need area? Well, by the way. Okay, yeah. So area of the base and area of the top both. So area of the base is equal to pi r square. So these are the formulas that you have to remember. That the area of a circle is pi r square. Okay. So it says that the height. So now usually we will denote the height by h, but we have a relation. So h between r and h. It says the height is 3 less than twice the radius. So how will you write that phrase in or translate that phrase from English to math? 2r minus 3. So h is equal to 2r minus 3. And now it is saying find a function that models the volume of the cylinder. So what is the formula for the volume of a cylinder? It is always any cylinder, you have area of the base multiplied by height. So volume is equal to pi r square times h. Yeah. So always area of a cylinder is area of the base multiplied by the height. So this becomes, what do we do now? Since it says give the volume, find the volume V in terms of its radius only. Now here we have found the volume, but it is in terms of the radius and height. So we have to get rid of this h. So what we do, we use that information that is given to us and we plug in. So everything is in R now. So we distribute to get 2 pi r cube minus 3 pi r square. So that is the model. Okay. This one, it says the figure shows an open box. So this is the open box, remember I mentioned earlier, with a square base. So again, base is square and they have already drawn the picture for you, and then you can see that this side is x and this, although they don't look equal, but since it has been written here that this is x and this is x, so we are going to take it equal. And the height is this one here, just being denoted by y here. So it says the box has a volume of 10 cubic feet. Express the surface area S of the box as a function of the length of a side of a square base. So basically in terms of x. So we have to express the surface area in terms of x. So in other words, we have to find the surface area of the box when we know this information that the volume is 10 cubic feet. So we just saw that the surface area is going to be the area of the base plus area of the sides. And since the base is square, all four sides will have the same area. But now we don't have the top, so the surface area will be equal to x square. This time we have the side is x. So x square plus 4 times x into y. Yeah. You can name the height y, you can name it h, whatever. But so we got the area, surface area, but this is not our complete answer. Why? Because the question is asking us to find the surface area as a function of the length of a side. So it's only in x. So how do we get rid of the y? Here we use the other information that is given. What is the other information? That the volume of the box is 10 cubic feet. So what is the volume of a box? It's going to be, remember, length times width times height. So length is x, width is x, and the height is y. So we have x squared y, that is the volume. And we also know that this is equal to 10 cubic feet. By the way, you should know the units of these quantities as well. So from here, this equation, x squared y is equal to 10. So we can find the y easily in terms of x. So x squared y is equal to 10. So this gives me y is equal to 10 over x squared. Now I will take this y and plug it in the v. So v is equal to sorry, we don't need the v, we are looking at y. Now we will plug it in the assay because we wanted to find the surface area, remember? That's what the question is asking us to do, find the surface area. So I will take this y value that we just found and plug it in the surface area. So SA, or just S, will be equal to x squared plus 10 over x squared times x times 4. If you want to keep it in the same order, just it will be 4 times. So we have 4 x squared here. Oh, this doesn't look like x. Okay, I'll rewrite it again. So x squared. So we don't touch this one term because this is only in x, it has no y in there. 4 x, they remain, and the y is 10 over x squared. Now you can see that we can simplify this second term, so you must simplify. So I end up getting s is equal to, or SA is equal to x squared plus 40 over x. So you can leave the answer here, or you can go one step further, take the common denominator and write it as x cubed plus 40 whole divided by x. So that is the model for the surface area.